Okay, over to you, Mahesh. You are the host now. Okay, so yeah, cool.
Yeah.
Yeah.
So good evening, Reni and Srinivasan. So we are waiting for more participants to join us. So we'll start in a couple of minutes. Thanks, Srinivasan. Okay, I guess it's okay to start now because now there's no point in waiting. So let's continue with the session. Okay. So good evening, and let me share my screen with you all. Just a minute. I'll just use Zoom whiteboard. Yeah. Okay. So in the agenda, majorly what we need to discuss is something which is called as a topic regarding unit testing. But before that, let's try to understand, a last discussion that we have had, which was around something which is called as a phase, wherein, more of, you can say, design phase. So wherein we discussed about, you can say, maybe UI design, or specifically design, and specifically something which is called as architectural part. And like as I said, these two designs can parallelly keep on running, which means the designing team can keep on doing the design, and the architecture team can actually keep on building the architecture for the application. Okay. And then whenever architect tries to design the application, ultimately there are certain principles that the architect is going to go and keep in mind. And then I did tell something like, you can say, there is something which is called as solid principles as a concept, which basically every architect is good at. And then irrespective of the what you can call it as a framework, you will find out architects can actually go and design a better and better what we call as classes, or so-called structures, or so-called, you can say, base classes, just because they are good at solid principles. Okay. There are very ground rules that every architect follows behind the scene, that by default the code has to be reusable. That's one part. Second is, try to chop the what we call it as classes in such a way that there is a unique responsibility given to each of the class. Okay. So if we take an example, I don't know whether we you recall this, but then the discussion that the discussion ultimately, will revolve around abstract application. But when it comes to designing the classes also, there are several number of things which come in picture. So like last time discussed, something like we can have so-called, let's say, what we call it as node level classes design first, which means so-called, you can say, child classes, I would say. And those very child classes that we will have, you may see some sort of, you can say, a duplicate code, which means if I define something which is called as, let's say, a user, maybe an administrator, maybe something which is called as customer, maybe something which is called as student or employee. Let's say when we see these people, we can always have something like, each one of them can have a name, each one of them can have some serial number, each one of them can have an address, age, gender, and whatnot. So you will find out, normally in such cases, what an architect would do is design the classes at, you can say, with the replicas, which means let there be name in each of the class, let there be address in each of the class, let there be so-called getter setter specifically for age and gender in each of the class, doesn't matter. But once done, then there is something which is called as simple observation, that observe the classes and try to identify if we can build something common out of it. Then try to extract a base class out of it, and then try to construct or try to think about it, that whether something should act as a base class, something should act as a what we call it as maybe rather base abstract class, or maybe an interface. So try to identify that. Okay. So a quick question: are we all aware of, you can say, abstract classes and something which is called as routine interfaces? I hope I'm audible. Am I? Okay. So I just asked a question, that is, are we aware of, you can say, simple, maybe abstract classes or interfaces kind of a concept? Okay, Srinivasan said he is aware of it. How about Bhanu and how about Matthew? Okay, great, great. Okay, so here it comes. Something like when it comes to something like let's say, as I said, designing the classes. As we discussed last time, we always start with the what we call as very child level classes. Okay, let there be replica, as I said. So take an example here. Suppose if we plan to create something of this sort, let's say there is something which is called as, let's say, mm, we try to identify there is a patient. Okay, so let's say here. So as far as abstract application implementation is concerned, here the application is something which is, I guess, the code base must have been shared with you. Okay, so let me do one thing. Yeah, let me get the. Okay, so there is one patient, let's say, that we have got. Okay, now a patient, as in so-called, you can say, if we have identify, a patient can have something like, let's say, a name. Patient can have something which is called as age. Patient can have something like gender. Patient can have something like, let's say, address. Okay, and they can be getter setters around it, which means I can just always have something like this, and they can be getter setters around it that we can assign. So on. I'll just take one simple example here. And obviously patient can have something which is called as some patient ID or something. Okay, so I would just have here PID as in some ID. Now what happens is, let's say if somebody has identified patient as a class in this case. Now obviously, I mean, this is very simple, but then I just try to, I mean, and some of you, I mean, already have passed this phase. Okay, so it's like this, and there can be something which can be, let's say, a doctor. A doctor himself can have a name again. Doctor can have an age again, but that's completely irrelevant right now. Okay, doctor can have here something which is called as, let's say, maybe age. Doctor can have gender, and doctor can have something like, let's say, an address, and doctor can have something which can be some doctor ID or something like that. Doctor can have something which is called as some certification. Then maybe, let's say, there can be a number of other things, something which can be, maybe, let's say, does he practice maybe some whatever pathy that we know that the doctor belongs to, and so on, some other fields. Point to understand here is, now obviously we can easily identify out here itself that these are the common things that we have got. Okay, these are literally common things that we can identify out here: name, gender, age, address. For example, address also, I'll just try to put here I address as well. So what happens here is, if at all these are common things that we identify, and then obviously we can think of like literally going for something like this, that we can actually identify some base out of it, and we can always have something which can be, let's say, a class person acting as a base over here. Just an example. Okay, when it comes to, so I can always have here, maybe, let's say, underscore name, underscore age, underscore something which can be called as a gender. Okay, and underscore something which can be called as maybe, let's say, an address or something of that sort. Point is, even after we have identified this, still there can be several other factors. For example, when you consider something of this sort, specifically, let's say, gender, when you consider, you will find out here only specific values can be assigned to a gender. So in such cases, we should not allow any person to basically assign gender, like, as and when, I mean, whatever that the person wants. So we should be ultimately fixing the values for a gender. And in such cases, what we can do is we can always plan to define something which is called as enumerators. So normally Java, .NET like applications do have something which is called as enumerators. And then inside enumerator, something like, let's say, maybe gender, for example, what we can do is we can always have here, let's say, male, we can have female, we can have other, as in another gender that we have out here. Okay, and then ultimately we can assign some initial values. Let's say maybe this guy, this means 0, this means 1, this means 2, and so on. Which means while the data goes in database also, I may not want to ultimately copy the gender content like this. So take an example. If there's a database table that we have, okay, consider there is a database tables like this. And inside database tables, suppose if I'm defining something which can be called as, let's say, patients table in this case. Okay, so if there's a patient table that we have got, obviously based on the understanding what you me we can understand here is, okay, there must be something which can be called as PID here. There can be something which can be called as let's say name here. There can be something called as age here. There can be something which can be address over here, and there can be something, yeah, so name, age, address, and gender, let's say over here. So if this is going to be so called, you can say, let's say patient's data specifically. Okay, if we say this is patient's data that we have got right now, and then finally there is a gender thing that we have got. Point or the problem which will happen over here is literally same thing I would want for doctor as well. So if I store literally doctor like details in another table, as it's a different entity altogether, I would see certain things getting repeated. And then obviously something which will be different over here is, let's say, this certification over here. Okay, some certification details. And here it can be something in which can be called as DID also. Okay, so ultimately this information which you see right now, name, age, and let's say related to gender, and the name, age, here also this information is so common. Okay, so why are we maintaining these many number of columns? So in such cases, just to ensure that these particular details are so called, you can just stored in a better manner, like instead of maintaining separate so called, you can say columns for that, what we can do is we can actually have another table constructed at a database level itself, which can be something which can be personal information. Okay, so personal information over here, and then that person information, maybe let's say it itself can be a table again. Okay, table person info, and then inside the person info we can always plan to have this information stored. Okay, so if at all this is so common information, why are we maintaining it over here? We can always cut it here. Okay, and then what we can do is we can place it over here that way. So if we place it like this, obviously this particular information can have some ID. Let's call it as P info or info ID, maybe IID over here. Okay, or PIID over here. There can be some sort of unique identifier that we can have out here. Now, after we have this PIID available with respect to the person, what we can do is we can always go and try to refer this PIID over here. Okay, so there can be patient's information, and maybe inside the patient's information I can always maintain something which is PIID. Okay, plus I can have patient related details, something called as, let's say, maybe let's say test, or let's say disease or something. So let's say maybe uh, disease, I'll just maybe I'll just sickness identified. Okay, maybe I can just specify some medicines. Okay, so we can always have this kind of, you can say, information retained. Okay, so they can be this information retained at what we call as personal info level, and I can always have these details, so what you can say, referred out here. So we don't have to ultimately go and maintain such kind of a details again and again in such cases. So this information I can just get rid of, and I can just put over here PIID again one more time. And the same PIID thing that we have, we can actually go and retain this information over here as well. So kind of, we can say, information which can be commonly retained or commonly maintained, it can be like this out here. Now, obviously, if at all it happens at, let's say, database level, now about the gender thing I talked about over here. Here also, if the gender is getting retained for all of them, in that case, gender can have, let's say, 3 values, suppose. So in such cases, what we can do is we can always define a table itself called as gender. Okay, and that gender table can have, let's say, gender ID. Okay, and I can always have over here, let's say, gender details over here. And then we can always have here 0, 1, 2 as an ID specified. And then I can always have over here, let's say, male. Instead of retaining these 4 characters every other time, maybe let's say female. And maybe I can always say over here something like other. So let's not maintain this one character, like one character equal to 1 byte. So for male 4 characters and for female maybe 6 characters and for other maybe 5 characters. Why are we maintaining it again and again? So in such cases, what we can do is here itself, since we're maintaining it out here, we can just maintain over here gender ID in this case, which can be acting as a foreign key in this case. So we can always plan to have something of this sort, and there is a relationship that we can have out here. So a gender ID will come from gender table ultimately that way. Okay, it can be something of this sort. Let me cut it down. Let me put it over here. Okay, some gender table that we can have, and I can always maintain this gender ID from here. So point to understand is at a database level, let the architect, a DB architect, do the, you can say all the, you can say magic. Okay, that is not something which is our concern right now, as of now. So at database tables level, we can do this. But normally when it comes to JPA, when it comes to something called as Hibernate, or when it comes to something like Entity Framework or in Hibernate in picture, you always find out it's a one-to-one mapping that we do all the time. So with respect to something which is called as, let's say, a patient, for example. Okay, so with respect to patient, I have identified this mapping, let's say. So we have got this patient table mapped with this class patient over here. What you see out here is this, sorry, this is patient. So this is doctor, right? As we talked about. So this is doctor details. So just like we have identified it. So what we have here is this is doctors table and this is doctors. So what you can say class that we have got. And then ultimately the person thing that you see, class, person, name, age, gender, address thing. Okay, so this information is something which is common. Okay, so either I can say it's a person info. Okay, so person info over here, and then what I can do is I can always maybe impose over here something which is called as so-called, normally what we say it as something which is called as composition out here. So there can be class patient over here, and this information that we retained, instead of we having it over here, we can actually have an object of person info over here. So I can always say some person info object can be over here. Okay, and here also what we can do is instead of we holding these details, we can always plan to have person info kind of details, hold over here. So again, the point is we can retain maybe information in this manner. Okay, all the time. Let me highlight it one more time quickly. So this is our patient's detail that we have got, and these are so-called, you can say, our so-called doctor details that we can have out here. Okay, and then obviously inside the person, this gender thing can be ultimately some gender ID also. So I can just say maybe something like this information can be pulled as in gender ID or something. Okay, point is very simple. One-to-one mapping is more important in this case. Okay, so if I just say class person info is actually mapped with, so what you can say person info table in the database. So it's one-to-one mapping we're talking about. Let's say this is mapped with person info over here. This patient class is mapped with patient table out here, and doctor table, doctor class is mapped with doctor over here, and enum gender is ultimately mapped with gender table in the database. So there has to be like, typical one-to-one mapping. And then if at all there is a so-called, you can say, some references that you see, it can be resolved with the help of something which can be called as composition. Okay, by default. So normally this kind of vacancy mapping is something which can be identified. So it was a very simple example, like simply identifying patient details and doctor details. But at a larger level, if you see a simple class that you design, it itself can be chopped into multiple number of parts. Right now, patient can inherit from person, rather patient can have something which can be called as, person info kind of a details inside it. So are we using composition instead of inheritance to get one to one mapping? So you can use, I mean, as I said, you can use inheritance over here, or you can use over here something which can be called as what I would say inheritance in this case. Okay, so as long as like some details, something like you can say you can use inheritance as long, suppose if at all there is a concept which is like let's say some sort of common maybe functionalities are there with respect to, you can say, patient and maybe doctor. I would recommend in such cases something which can be called as not exactly what we call as composition. I would recommend having inheritance in this picture that way. Okay, but then if at all, I mean, this can be resolved in couple of ways, which means if person info can be interacted isolated manner, if person info can be interacted in isolated manner, then we can very well go for composition. If at all person info cannot be interacted in an isolated manner or may not have that much of meaning, okay, in isolated manner, then I would definitely look at it as, you can say, a common things which can come up as so-called inheritance in such cases. Okay, so one way is you can actually have a person info, maybe object inside a patient, or other way is we can always go for simple inheritance in this case, which means what you said is absolutely correct over here. I can think of this as person info, maybe acting as, you can say, or may not have an individual kind of existence. In such cases, I may not go for composition in this case over here. Okay, and in that case, maybe I will identify that I inherit from a person info. Rather, instead of calling it as a person info, I will start calling it as so-called, you can say, person class in such cases. Okay, so at so-called, you can say, maybe a table level, you will find out person detail or person info can be there, which means person info or the person can act as, you can say, person class can be represented by person info table, but then it can be represented more like an inheritance in this case. Okay, it's like, person has a something. Had it been something like, you can say, whenever has a relationship, something like patient has a person info, okay, or patient is a person, so that also matters, which means your naming convention also matters in this case. So patient is a person and doctor is also a person. Then if at all there are some common functionalities, I would see, I would always go for defining person as in base class in such cases. And that way what would happen over here is something like this. I always go and put up over here this as so-called, you can say, a base in itself. Okay. And then I'll simply inherit the class person into patient and doctor. But when I represent this in the database also, I may represent this as a personal info. Okay. I may represent this as so-called, you can say, person itself. Okay. Person details out here. And then whatever is a person ID or info ID, I can refer it inside a patient and I can refer it inside a doctor that way. So you can always see here, whenever references exist, database can have those what we call as references retained. But how references are supposed to be presented in case of class way also, they can be a composition and they can be simple, something which can be called as inheritance in this case that way. Is it implementation choice like any other better than other? I would say, as I said sometime back, something like we can say individual existence does matter in this case. So it's more or less like here, can class person, I mean, just take an example here. Something like, let's say, I can always have an employee, okay, class. And I can have an employee has ID, EID, employee has ename, okay, and employee has department is there, department ID is there, okay, out here, department ID is there, and department name is there out here, department location is also there, and so on. But then when I look at what we call a single responsibility principle, one of the principle from solid principles, what I can see out here is this, that these things, they don't represent employees details, they ultimately tell details, like you can say where employee works. So these are not individual employees details, these are more, you can say, department specific details that we can have. So instead of we retaining this information for every employee over here, why can't we define a separate class altogether? So we can always plan to have something which can be so-called, you can say, maybe department as in another class out here. And if I define department as in another class over here, then obviously I need some association between these two guys now over here. Now I cannot use inheritance over here because employee is not a department, right? In here. So employee is not a department, rather employee has a department. So what sort of relationship ultimately suits? Based on that, you can always take a call over here that employee has department details. So I can always say here, there's going to be something which can be department object over here that we can have. So employee has a department. So in this case, I'll always go for composition. In this case, I won't be going for something called as inheritance. But here, patient has something which is called as person and doctor has a person, won't go well. Other patient is a person and doctor is a person. So in this case, inheritance will matter most. So ultimately it's something which is so-called, you can say, can these objects individually exist? If yes, ultimately, can one object, ultimately, can I say one object is other object? Or can I say one entity is other entity? Logically, literally in English words. If I can't, can I say one entity has other entity? If yes, I would go for composition. Otherwise, I won't go for composition in this case. There can be several situations, something like in this case itself, I can always say department has employee. Just like employee has department, similarly, I can say department has employees over here. So they can be employee has one department, but department has got many employees in this case. So that way, department can ultimately have a kind of, you can say, reverse, maybe so-called, you can say, reference of employee collection in such cases. So point to understand is, if I go to department and if I ask to a department, okay, how many employees do you have? Show me the list. So department object individually should be able to get me all the list. And then that way, whatever list I get, I should be able to query to a individual employee object, tell me your name now. Similar way, vice versa, if I just go and ask every employee that tell me your department details. So ultimately, employee has a department object. So I should be able to ask, get me the department details, and I should be able to find out department name, location, and ID. And that way, I should be able to get back to something called as employees collection itself. Means there can be some sort of circular references as well. But then here we need to ensure that how those references ultimately are scheduled, so that those references are going to one matter most. Okay, so employee has a department and department has employee collection. Ultimately, that relationship can be employee has one department and department has many employees, kind of a, you can say, relationship we can always end up with. So whether it's a either and whether it's a has a kind of a relationship. So we will have to take a call based on what sort of classes we are designing and developing. Okay. So hopefully you can say these are something which is like, you can say, we come up with so-called, you can say, a classes first. Let there be classes with some duplicate content and columns and maybe properties all the time. But when it comes to something what has duplicate things also, let us not sort them immediately. Let's take time. Let's try to look at the classes. Let's observe the classes and let's try to figure out whether something should act as a base class, whether something should act as a separate class, and maybe we should always have something like association anywhere. So we always will have to figure it out. So normally architects would ultimately take a time. So it's all, as I said last time, something like it's always a down to top kind of approach. It's a bottom up approach. We always design the node level classes first, and we gradually grow towards the base. And normally, to identify the base classes also, as I said last time, there is something which is called as solid principles, which are definitely going to help you understand how do we go and design the best base classes, or design the best base. I should not say classes even, because that way, we will be only stuck with classes, but there can be something called as abstract classes. There can be something called as interfaces in case of Java, .NET, and languages like that. So you'll find out then obviously what we need is we need to identify better base. So rather every time there are some ground rules as well, which means some identified rules, I would say. Something like, you can say, whenever there is a assurance of a sequence that we need, I'll always go with something which is called as abstract classes. Whenever I would just need some sort of compulsory implementations, only implementations and only declarations I know, I would always go for something called as interfaces identification and so on. So obviously by practice, people can identify, easily whether it should act as a base class or whether it should act as abstract or whether this should act as an interface in this case. But then you have to be like very good at solid principles. Okay. And believe me, I have gone through this. It's something like, you can say, one principle only you follow religiously, and you will be forced to follow all the other principles automatically. You just have to be, you can say, stick to one of the principles. Pick up one principle that you can say, what we call it as understand most, and then what you can do is you can actually go and maybe stick to that principle. So point is, if I go with something which is called a single responsibility principle, the first one, it simply says a class should have single responsibility. As I said last time, single responsibility doesn't mean a single function. It means logically it should be single responsibility. So if employee is there, employee should be able to do what employee does over here. maybe getting the department location, and maybe something which is called as getting the department branches and so on. That's not employee's concern. That's the department's concern in this case. So let's not burden employee with some sort of, you can say, functionality which employee should not have. Let us try to isolate and create a separate class called as department in such cases. That's where so-called, you can say, single responsibility principle comes in picture. So identify and create many classes as you want, and then try to relate these classes using simple so-called, you can say, maybe inheritance or typical association. Okay, so when it comes to something which is like, you can say, solid principles, this actually makes more sense. As I said, one principle you follow, you will be forced automatically to follow all other principles. So once the architecture part is done by an architect, normally what architect will offer you is very simple, so called, you can say, base classes collection, abstract classes collection, or so called, you can say, maybe interfaces collection. Now, collection, or you can say classes, interfaces, base classes in the form of some sort of libraries. So based on, you can say, who is going to go and develop, is the architect from the same team? Is the architect hired specifically just to design the what we call as architecture? Is source code or IP supposed to be shared or not? Based on those concerns, you'll find out architect may be sharing the code, or maybe so-called, you can say, getting you so-called, you can say, simple, maybe compiled libraries. So imagine a situation in Java, I would get something called as typical jar files, or in case of .NET like technologies, I may get something like, you can say, .dll files, or something like .headers from, you can say, C++ perspective. So I would get some bases, and those base classes is something which I would start using in maybe application. Once the architecture is done, once the bases are done, those base classes are ultimately base, I can say, things are shared with the end, I would say, developers, and then developers based on the responsibility will start implementing the base classes and base implementations, and then they are just supposed to go and end up writing code, which means if you ask to a routine developer, that developer may not have a complete vision of, you can say, how exactly and where exactly his or her code is going to get used. But then if you ask to an architect, he'll have a complete vision. So point is, developer may not have a complete vision, architect may have a vision in this case. So point is, once you have base classes given, then developer will start implementing it. Now, several times what happens is when a development starts, okay, once you have a better base classes design, developers job is only to code. Okay, just end up getting something which is called as a stub, and inside the stub, what you do is just keep on filling the code. That's what developer will keep on doing. But there can be some other situations as well. Something like when developer is given a chance, developer may have to ensure that he understands or she understands the functionality needed completely. What does that mean? Take an example here. Let me clear this. Let me come to another point. If you have heard of this particular word before, something which is called as test driven development. Have you heard of this word before? Ultimately well known as TDD. Okay. Have you have heard of this word before? Okay. How about others? Okay. Yes, that's correct, Srinivasan. Okay. So let's do one thing. So it's like this. What you do is, in such cases, is it similar to A/B testing? I would say so. But then maybe you will be able to figure it out once we put up some example in front of you. So it's like this. Normally what happens is when, let's say, a typical development starts, let's say now you have all architecture and everything ready. Okay, now whether code written by a developer is something which is which is as per the expectation, and as per the what we call as correct understanding or not, how exactly developer can ensure that. So couple of approaches we have over here. Take an example. A very simple example would be something like this, that let's say a developer is asked to write down something which is called a simple calculator like functionality. Okay, I'm just taking a very simple example to understand. So what developer would do, developer is supposed to go and write down some class, okay, which is simple calculator class, wherein add, subtract methods are there, which developer is supposed to go and ultimately, write down some, maybe take some input and do some addition. So normally what you do is there is something which is called as individual functions testing that we do. Obviously, how do we do the testing? So point is something like this. There can be some frameworks which will ultimately, help you do that. Take an example. Consider some main method of maybe Java, maybe .NET or C++. Consider, okay. And what is expected by, you can say a developer is this, that whatever code I'm going to put in front of you, let's say that code should work. Okay, take an example. Okay, so it's like this: calculator. Let's say calculator or calc equal to new calculator. Okay, let's say it's a class object creation that we are doing right now, and this calc object that we have over here should ultimately have they expose a method called as add, and then it should basically take up some parameters over here. So I can always say there's some parameter like integer x, okay, initially equal to 10. I'll have over here something like integer y equal to 10. I'll have over here something which is like, let's say, maybe expected is equal to 20. See, before you write down any kind of a functionality also, you'll always know what exactly, what will you provide as input and what will you expect as output, because some sample will always be with you. Something like you will always know beforehand, something like you can say when known inputs are given, okay, some known inputs are given, some sample inputs are given, you will always know what a code should return to you. So ultimately what is expected? Output. So ultimately add should return me expected like 20 ultimately. And then I will have over here something which is called as actual. Okay. So let's say integer actual is what we have out here. So now take an example, calc.add, whenever I call, I'll put up x comma y over here, and I will say something called as actual is equal to so and so. Okay. And then I need to simply compare over here if, okay, something like actual equal expected. Yeah. So if the actual equal expected, I can just put up over here something called as, okay, maybe the code is okay. Okay, else code is not okay over here. I'm just putting it over here. Code is not okay, let's say over here. So point is, let's say this particular piece of code should work for us. This piece of code should work for us. Now the thing is here, it may happen that this piece of code is written in some, you can say, project. Okay, so somewhere in some project, let's call it as testing project over here. So somewhere in the testing project, what we have done is, let's say we have written this piece of code. So imagine a scene, there is something which is called as, let's say, a void main over here. And let's say I am simply calling it out here. So let's say this is how it goes. Let's close this out here. Other why to, put it like this. Let's cut it from here. Let's put it at the top like this. And let's have a closure as well out here. Okay, so let's say this is, a code written, but this is something which is just I'll call it as a test project or something which is called as a test case. Okay, simple test case that your code should work, but ultimately you normally will see that there will be several number of, you can say, zigzag lines over here, which means as and when literally, let me highlight it somewhere out here. Literally, you will find out if you end up, maybe let's say, suppose if you start writing code like this, you will end up in problem like this. That first problem will be something like some zigzag line will tell you over here, sorry, where is this calculator thing existing in the first place? I don't see any kind of a calculator over here. Yeah. So take an example, you will end up in an error, calculator does not exist. Okay. So if you end up writing code like this, imagine a situation that you end up in an error like this. Calculator does not exist. Okay. Calculator does not exist. But you already have written a code. Obviously, without IntelliSense, without any support, you have written this piece of code, this much of code, just like I have authored just now. And then whenever you end up in an error like this, now obviously your job as a developer would be something like this. Resolve this problem first over here. Here comes a solve. I mean, solve this problem, first problem or a first zigzag line. Solve this. Solve this by doing what? Solve this by writing one class, maybe in your application. So write a project. Okay. Write maybe something which is called as, let's say, maybe some project, which is, let's say, literally some Java project now. Okay, create some Java project. Okay, create a class file, and inside that let's say create class called as, maybe let's say, calculator. Okay, calculator does not exist, so solve the problem now. I would say solve the problem over here. Solve by coding. So now calculator class exists. So obviously this problem you have fixed. Okay, you compile this code. Okay, you compile this code and try to refer it into your application. Okay, so now you simply refer this in your application. Now when you refer, obviously this error will be gone now, which means calculator calc equal to new calculator, this problem won't be there. But now there will be another problem that you will see, something like, so called, you can say add not found over here. So there will be another problem that you will see over here. Add does not exist over here. Add not found, let's say. If you end up in error like this, since you already have resolved this problem, right? You are already solved this problem now that we have here. Let me highlight this. So you are already solving this problem. So you are done with this problem now. Now add not found. So obviously you will create over here some function add. Okay. So if you create a function like this, void add, and so called, you can say no parameters at all. And suppose if you create it like this, then you will end up in another error, something called as add, so called, you can say signature does not match. So you will not get error like add not found. You will get something called as add overload with, so called, you can say parameters like two integers and return type like integer not found. So sorry, add is found, but add does not have a signature that we desire to use. Then obviously you're able to resolve that problem as well by simply expecting over here something like, let's say, integer x or integer y, and then by simply returning some integer from here. It won't let you call that method unless until you simply say it's a publicly available method over here that way. And then finally, once you have this, you need to return something. So you will end up writing actual logic over here that way. So once you end up writing, so called, you can say code like this, method and return content with proper parameters and proper return type. Once you ensure this, then this error or the error that you see out here will be gone, which means now there won't be any error in your actual code as such. Okay, which means now you won't end up in any more errors over here like this. So ultimately your this code will work, this code will also work. But then what logic you have written over here? So did you write the logic like, let's say x, maybe let's say y plus 3 for some reason? If you have written x plus y, then obviously here there is going to be some problem now, right? In this particular case, so expected will not be equal to actual, and in this case you will end up in something which is called as code is not okay, right everyone? So here, just to ensure that this test case passes, we just want a assurance that, so what I can say, this particular test case that we have written, this test case passes successfully over here. So ultimately, number of times what happens is, let's say in a test driven development, test case is written first, which obviously is supposed to fail first. And then you keep on satisfying, you can say each and every, you can say aspect of it. So you keep on satisfying, okay, calculator calc equal to new calculator doesn't work. Let's create a calculator class. Let's create an add method. Let's take these parameters. Let's have so-called return type maybe, a properly given. So you keep on solving one problem at a time. And then once you figure out, okay, this is, exactly what I really wanted. Once this thing passes, okay, well, then you can figure out, okay, I'm done with my code in that way. But is this the only thing which is expected? May not be. What will happen if somebody tries to pass on a huge number? Let's say integer. In every language, when it comes to, it will always have a maximum and minimum value put up. What will happen if at all I put up a very, very long value as an integer value? What will happen if I put a float value? Obviously, float value maybe at compile time itself, we will end up in a problem, which means this case, test case, the left-hand side project may not work. Then obviously, suppose if I pass on integer value, but a very, very big integer value, if I pass on, okay, which is not in range at all, then what's the output expected in such cases? Then obviously, have considered those cases? May not be. In such cases, here there can be several situations, which means just like we did this, okay, instead of calling it as a main method now, I will start calling it more like, okay, let me delete this highlighted content because it won't let me type here. Instead of calling it as void main, I will rather put it as, okay, it's a testing project, but this piece of code that we have written, okay, just now, I would simply say, this is something which is going to be something which is called as, maybe let's say test add. Okay, so test add itself is going to be a method, and that method will ultimately have this kind of, you can say, logic written over here. So literally you will find out that we will have situations handled in this manner. We will have, for addition of a test, I will have this test case written. Okay, for the addition of test, I'll have this test case written, and this particular test add is something I can just very well go and test over here. So I'll call test add out here. So there is going to be some, you can say, different project called as, let's say, testing project. Okay, and that testing project will have all these details mentioned. So I guess there is some problem here, so let me pick it up like this. Yeah, so point is, we can have some project created, okay, a test case. Ultimately we call it as, this is called as test case. Meanwhile, whatever we have written right now, it can be called as test case out here. And then what happens over here is this. Let me highlight it again. So what happens over here is, you create a function, okay, in some testing project, which is just going to create a calculator class object, expected and actual should meet, and then it should be like, desired content. But there can be another situation here itself, something like, you can say, there can be another test case here itself after that else is over, where I've written that, test case word just now. There can be another situation, something like calc.add, I will call again. They can be integer x1 y1, okay, and then I can have some very long integer put up there, and expected value is something like, you can say, expected can be, you can just put up expected whatever you expect, and then in actual what you get. So if at all there is a huge value that you put up, obviously huge value may not be there because you are out of range in such cases. Okay, so there can be some runtime exceptions that you end up in. So how you have logically handled such kind of a cases in your application, which means what if there is a problem which occurs in your code? So did you write down over here something which is like, try catch block, which means you have authored the code, but then did you write down over here try catch? No. And obviously the problem that we have right now is, if the code fails, there is nobody to basically catch the exception and graceful finish. So ultimately you will be forced to write down such kind of a things. Then what if I pass on some sort of wrong values? What if typecasting is expected over here and I don't typecast in a proper manner? So right now it's a simple addition, so I may not actually go and expect so many things. But point to understand is, there are several situations wherein, you may have to write a try catch block. This is only x plus y we are talking about, but there can be situations wherein I'll actually expect, you can say, much more than simple, you can say, actual and expected comparison. Which means sometimes it happens that I may not get something in return from a function. Sometimes it may happen that the function doesn't return anything, but function simply, does something with some object. Take an example over here, something like, there is a function which is called as do a status change. Okay, simple status change. Something like, let's say, whenever some parameter is passed to that object, okay, what it does by reference, it simply does the status change, some status change. So obviously that function doesn't return me anything, but that function must be doing something with some variable. So ultimately what you need to do then is something which is inconclusive. Okay, we can't conclude something somewhere. In such cases, we have to find a way that is there any way that I can just check that whatever that function did actually, it makes sense. So in such cases, what you have to do is you will have to sometimes not compare actual equal expected. Sometimes you may want to compare something like you can say some values. Sometimes you may want to go and maybe check whether value is greater than something or less than something. You may want to check something like whether value is not matching at all. Okay. You may want to check like, value did go through iterations or not. So there are several number of cases. Okay. So there are several number of cases wherein what we have to do is we will have to ensure that so-called you can say these checks can be performed. Okay. So let me put up over here. I'll just put here allow to talk. Okay. I hope you'll be able to talk now.
Thank you, Mahesh.
Yeah. So this is, I mean, normally if you end up writing this first, specifically, if you end up writing so-called you can say test case first, okay, and then you end up writing code, okay, out here on this side, then I would say something called as test driven approach is what you have followed. Okay, this is something which many of the people recommend, but then normally what happens is when the project starts in actual, normally project starts with a with literally a lot of expectations. Project normally gets triggered, so people who are eager to start with test driven development, they they start writing test cases, and then ultimately some people would go and just start writing the code according to test cases. But then in projects what I have seen is it's that enthusiasm of something like writing unit test cases first, and then writing the actual classes like calculator and maybe add method and subtract method. We'll find out that you can see enthusiasm somehow goes down, which means because of a number of things, because of some runtime changes suggested by client, because of you can say you started with something, and then later on what happens is the changes in a code versus the expected thing in the ut, which means ideally in such cases you should do the changes in ut first and then do the changes in case of code. But then because of the rush, because of the what we call it as expectations to finish many things faster, you will find out what many developers do is they ultimately end up doing changes in the code first. Okay. In test driven development, normally what we do is we do the ut first and then we actually end up writing the code. But then normally projects do, you can say start with a actual, I mean it's like it's on track. But then as and when so what you can say basic part is done, then eventually the project ultimately goes in a different direction. So architectural and class design will be the base for both TDD. Yes, definitely, definitely. I mean, I mean, whatever we are talking about, this is ultimately your coding classes, not the ones which are going to want to define your structure, which means we are talking about some classes which ultimately will involve the actual logic. Okay, their functions will involve some logic. So once the architectural part is done, once the architecture based classes and interfaces are design based classes and things handed over to your actual developers, then actual developers would ultimately end up writing code like this. So ideally in a test driven development, people should write the unit test first, then they should code. Okay. But then as I said some time back, many projects that I have gone through and I have seen, what happens is people start with the enthusiasm, but then eventually what happens is based on some client's expectation and based on the delivery, what people do is people forget about UTs and people ultimately end up making changes in the code itself directly. But then obviously several number of times it's written in MOUs signed with the or SLAs with the client that the unit tests something, it should be working all the time. So several number of times unit testing frameworks are there, which means what I said, testing project, what I said is a wide main. Ultimately, you don't keep on calling test add out there. Okay. Which means the first 4 lines of code, which I have written void main and test add on the left hand side, you'll find that that particular piece of code is not something that we keep on doing. Ultimately, there are so-called you can say frameworks and what we call it as tools available ultimately, which will just simply find out the test add like functions in your code. Okay, and they will simply start executing those code snippets automatically. And then if they find something which is called as this thing even, something like actually equal to expected, we don't actually go and end up writing something like this. We don't even end up writing something of this sort, like actual equal expected by ourselves. We don't do this by ourselves. Okay, this is not something that we do over here. Rather, what we do over here is this particular framework that I'm talking about. Okay, I'm just going to go and highlight it quickly. Yeah, this thing that I'm talking about here, this particular part is something which is managed by somebody, which is actually called as some framework. So there is something which is called as JUnit. Okay, as a framework. There's a JUnit framework. There is, for Microsoft.NET, there is something called as NUnit as a framework. Okay, and there is something which is called as XUnit and so on. So point is, these unit testing frameworks, okay, are going to go and provide you this thing, which is called as, you can say, this this main method and so on. And they themselves, like frameworks, are going to go and simply look at, so called, you can say, this piece of code. Okay, is there a test ad available? Or they always will find out some specific functions with specific, so called, you can say, maybe attributes, some metadata. So there is always a trick to write down such kind of, you can say, maybe code snippets, which means they won't ultimately go and execute each one of your code. They will only look for some specific things. So there is always some syntax specified by JUnit and NUnit like frameworks, that you should ultimately end up writing such functions on the left in this manner. And then even these frameworks like, JUnit and XUnit, they won't let you, do something of this sort. They won't let you ultimately, do this comparison by yourself over here. So you don't do something of this sort by yourself. Rather, what you do is you try to use their inbuilt functions. Okay, so you use something which is called as, let's say, assert dot suppose equal over here. Assert dot maybe r equal, let's say, over here. So you will end up writing assert dot r equal, and then you will put up over here actual comma expected over here. Means here assert ultimately becomes some inbuilt object from JUnit and NUnit, and then they will give you a method something what is r equal, and then you just pass on here what is actual and what is expected, which means you yourself will never do this kind of, you can say, comparison while you actually go and end up writing unit test cases like this. So you won't do this by yourself. You will rather use something which is given by so-called your inbuilt functions, which are given by your so-called, you can say, JUnit and NUnit like frameworks there. So these frameworks will give you this. Now what's the, you can say, thing, what is the importance of these using assert.r equal and so on. So you will find out
Mahesh,
ultimately what happens over here is assert.r equal like functions, when you keep on calling r equal, r not equal, less than, greater than, and many other, something called as inconclusive. Whenever you end up maybe writing code like this, you'll always find out these frameworks like JUnit and NUnit will ultimately give you literally, so-called, you can say, presentation. Even on a console, they will give you presentation like this. Something which is called as, this was a test case, right? Just a minute, Ravindra. So they'll actually give you some details like this. So whenever you run the actual code, you will find out, let's say there's a test add, suppose the function that you have put up over here, test add, and they'll simply tell you something which is called as, okay, passed or failed over here. So passed or failed. Maybe let's say test subtract over here, and they'll tell you something like, okay, this is something which is called as, let's say, passed and so on. And ultimately they will simply present it in many of the frameworks, ultimately including this, they'll present you in, so-called, you can say, color combination format, which means if it is, so-called, you can say, passed, if something failed, for example, over here. So take an example, something fails out here. So I would see something like, let's say, test division, suppose over here, and test division ultimately failed. If I see over here, let's say failed. Now I literally would see a different color combination, more like this. Okay. Here, let's say, and this particular guy, I'll just try to put up over here with some different, okay, I can't, give me a minute. So I'll put it like this. Meanwhile, I'll cut it from here. Okay. And maybe I'll just put it over here with some different presentation out here. Let's say this is the one that we're talking about. So point is frameworks like this, so what you can say NUnit and what we call it as JUnit, they ultimately will present you in this manner. Okay, and normally there are some third-party utilities available which will ultimately convert this thing into so called you can say some presentable content, like you can say HTML or a PDF file out of it. Okay, you can convert this test result in the form of PDF and HTML file. And normally many of the customers or clients will expect from you something of this sort. They'll expect that your HTML and PDF that we have got, they ultimately, you share it with client. Okay, and whoever is a so-called you can say technical person or POC at the client's end will simply go through this, and the expectation that the client and technical person will be something like he should be able to see over here all green is something which is expected over here. This is the expectation that the end customer will have over here. So as I said, normally what happens is when test driven development starts, you do all the test cases first, you do write the code against it. Okay, you write down this piece of code first, and then you try to satisfy this code by writing some maybe actual classes. But then over the period of time, because of the rush, because of the expectations, and because of the time limit, what developers do, it developer keep on doing changes over here itself based on the need, and then ultimately they don't do changes over here on this side. So ultimately, whenever some expectations that client expects, like okay, share maybe at the end of, let's say, maybe 2 iterations, share at the end of, let's say, maybe sprint, what you do is you share this UT with me, UT results with me, unit testing result with me. And ultimately UT results, you will find out many of them are failing because these unit test cases are not updated because of the compared to, you can say, code updates which happened over here on the right hand side. So normally many developers try to do a lot of things. Yes, you would say so. I mean, there are several frameworks available, just like JUnit and NUnit that we have got. There is something which is called as for mocking up. There is something called a mocking test is there. If you are talking about something like, you can say, client-side frameworks, something like JavaScript-related frameworks also, there are several other. Something called as, you can say, there are test runners, there is a Mocha, there is a Chai, there is something which is called as, you can say, I would say Enzyme. There are a lot of, you can say, testing frameworks which are available in the market, but then JUnit and NUnit, these are the pioneers that we have got. Okay, so normally expectation wise, client would simply expect these all should be green over here. And then obviously, just because you kept on doing changes on the code side but not on the UT side, okay, UTs are not updated based on the code. So obvious, I mean, it should be reverse. UT should be updated first and then the code should be done. But because of the approach and because of the rush, because of the what we call as time limits, you'll find the developers do wrong things, like they do changes in the code first and then they don't update the UTs. And then several number of times, after a lot of hassles, what happens is people ultimately end up like making one iteration, or I mean, I would say it's not ethical, but then many people do this. Something like, you can say, they finish the code first, they ensure that everything is working, and then people actually go and try to update in the leisure time or in some time frame when some developers are free. They'll be asked like, you do update the UTs now all the time and ensure that every UT is working properly. This is not good. This is not as per the, you can say, as per the TDD, but then many developers do that behind the scene. So this is something that we do. Now in case of our what we call it as Upstack application that we have got, in Upstack application we are simply using JUnit. Okay, so ultimately it's just a mock-up that we have to do, which means some functionalities which are written, we just need to test it. So I'm just going to go and open some code for you. I'm just going to go and show you that there is a code available and how does that code work. As I said some time back, test add function, if you return that test add function execution is all dependent on this JUnit and NUnit. Okay, but this test add function, how will they find it? Which means if I run my test project also, how will they find that we have to run the test add function, and there can be several other functions over here. So why will they run test add only these functions or these frameworks? So there is a reason behind it, like why exactly they will run, because there will be some attribute and some metadata available on top of those functions. So ultimately, what does that attribute and metadata mean is something which matters over here. Okay, now Ravinder, your question, please go ahead. Or was your question already answered? Like, if there is anything else, please ask. Did we all get it? Okay, Ravindra, thanks. As I said, ideally the TDD should be, it should be so, I mean, people should be ethical in, doing the TDD development. People do say, they know we do test driven development, but then people do write the code first and then they write the UTs. That's something which I've seen. I've even seen several number of projects wherein what people do is when client says, I need every test to be passed also. What people do is people do something of this sort. I have seen this. What do they do is this, in this add method that you see right now, okay, out here, what do they do is they literally, do something of this sort. Okay, you wanted to return something, right? So something like, let's say, return maybe something like 10 over here. Go to the unit test and literally, put up over here itself, expected is 10. Literally on this side, expected is 10. Return 10 over here. Don't worry about the logic. Comment the existing code that we have got. This is what I have seen people do behind the scene, just to ensure, and just somehow, to tackle the what we call as pressure that they have, the work pressure, I mean to say. So you'll find out people do this very, very often in, applications also. And somehow this is, this is nonsense, but people do it. Yeah. So, and then obviously these things will be, this is going to go and ensure, good code quality. As long as more number of unit test cases you end up writing, more number of, you can say, expectations you put up, like expected result is so and so. So more expectations, and then what we call as better code you will end up writing. So try to, I mean, UTs are very well going to go and help you, build the project and tackle every situation that way. I mean, is the situation handled or not? And then normally while you design UTs also, the what we called as testers can also help you in that regard. I mean, writing UT is a developer's job, but then ultimately UT's discussion should happen first. So there, some testing team members and the developers or the architect, they themselves can sit down and they can identify, okay, these are the test cases that we have got. Obviously, it seems very boring, something like, writing the UT first and then maybe writing the code also. But believe me, it's fun. I mean, it seems I'm very sure about it. Like, for a core developer also, it seems very boring. Something like writing UT. Okay. And this is something which is developer's job to test the UT as well. Okay. And after you are done with all the development and UTs, when every UT passes or every UT is cleared, what you do is you ultimately hand over that code for, or you give a build to the, you can say, tester, and who would ultimately go for something which is called as, you can say, maybe regression testing, something called as load testing is something that people will do. Okay. Even regression testing is something which, is up to a developer again, which means based on the code which is checked in, you can say beforehand to the tester, developer can simply check based on the code changes done just now. So is my previous code is also working? So code changes done today, and maybe let's say 10 days before code is failing. That is something which is not going to one, welcome. So ultimately we need to ensure that just because of these changes, some other code snippets are not failing. So that is something we need to ensure. Load testing is something, that, mockup can be done by the developer, but then at the end of the day, testers are also there who will ultimately go and test, functionalities at their end. And it can ultimately, come back to the developers, and then developers can very well go and do the changes and give a build again. So there's always, you can cycle, which means, a ball can keep on, being in testers, you can say, side or developer side. You just keep on, switching this, you can say, to and fro. Okay. And many number of times, again, as I said, what happens is number of times it happens that developer's machine has a code. There is always a configuration made. There is, let's say, some log file. For example, I'm just getting a log somewhere. Whatever is happening in my application, I am simply retaining a log on a C drive or D drive, let's say. So I assume that there is a D drive available. And then I created a build and I gave it to the tester. And tester keeps on telling me something like, you can say, your code doesn't work. Okay, the log does not get maintained. Without, or several number of times, some inputs are given by, let's say, a tester, and then some configuration settings or environmental settings are not there on the tester's machine, and which we forgot to document. If the code doesn't work, tester would simply, convey this doesn't work. Maybe code abruptly breaks or application abruptly breaks, not code. application abruptly breaks without any warning, without any message. And whenever such things are conveyed back to a developer, what happens is, now obviously developer will try, you can say, doing it, but several number of times there is a limit again, which means developer is coding and side by side fixing the bugs for, you can say, yesterday's build or last week's build. So you will find out then those bugs solving, which are, given by a tester, that itself is an add-on task. And then what I have seen is many developers ultimately, just to buy out some time, they convey in their comments to the tester, no repro. I can't reproduce this particular situation at all. So whatever situation you conveyed, this situation doesn't happen on my machine. It won't happen because developer's machine is always the happiest machine. Okay, which means everything works on developer's machine. And then finally on testers or staging machine, it doesn't work. And then ultimately here, tester is helpless in this case because tester is not a developer who's going to convey like, okay, these are the inputs I've given and so on and so on. But today there are several, good tools available which will ultimately, reverse engineer to some extent on a tester's machine and can tell you upfrontly some track. Okay, these are the things. This is the, you can say, problem where, this is where a problem has occurred. Several testing tools today can take a memory snapshot and can ultimately give you a memory dump of tester's machine to a developer. And whenever developer tries to run the code, that tester's machine, what we call it as mapped, a memory map, is something which can be mapped with your application's memory now, which developer is running, and then developer can be brought to the same line, where code breaks. So you'll find out there are several advanced tools are available right now, so that developers have no choice now to say basically something called as no repro or something. There are way number of tools, rather testing tools are advanced now. But then UTs are, is the first step that, developer, ensures that the code is basically working as per his or her understanding. Okay. So in our application, which is, let's say Upstack application, I just have Upstack application code in front of you right now. So you'll find out whatever code base which is shared with you. Okay. I have some installation issues, but then I'll just go through the code. So in this case, what we have here is in this application that you see, we have here src main Java. So ultimately our main Java source code is over here. And then there is, barring that main, there is something which is called as tests over here. So ultimately it has got something which is called as a test, what we call it as a UT code that we have got. So if I just expand this with respect to Java, there are several, so what you can say, modules which are created. So there is a authorization module, there is a configuration, there is the exception handling, there's a test request and users related code. So if I just go to something which is called as test request, for example, okay. Now, if I just open over here, something which is called as, let's say, test request. Okay. So if I just go to test request controller, for example, so test request is there. There are several functions that we have got out here. So test request is simple entity class. Okay. Based on JPA, which means ultimately table is mapped with respect to this class that we have got. There are also codificated some members that we have got out here. There is some code base over here, which is called as, let's say, create request, for example. Okay. So what create request does, this post mapping in the sense, whenever somebody shoots a request to, whenever I run my application and whenever I try to shoot a call to API/test request, ultimately a post request to, just like get, post, put, delete, different types of requests are there. So ultimately from my browser or from some tool, whenever I raise a call to API/something.com/API/test request, ultimately that request must come down to something which is called as create request. Okay. Create request will ultimately collect all the data that we have got from the request body. Normally it's a HTTP request, always will have a HTTP header and HTTP body. So from the body part, collect the data, and that data will be something which is called as object of type create test request. Now, if I say create test request, if I just go and maybe say, go to definition, okay, implementation, you'll find out what will be there inside the request body will be name, gender, address, age, email, phone number, and pin code. So this much of data will be given by somebody. That data will be collected from the HTTP's body, and that data will be, so what you can say, that object will be used. That object will be used, and then we will have over here something like this data used for creating, so what you can say, another object. So I will have another object created called as test request object, and that test request object will be given. So out of that name, gender thing, you'll find out there will be, so what you can say, current logged in user details will be fetched. So user details and some gender and name and other details that we have got. Okay, so based on that data passed on to create test request from, you'll find out what happens is there is another object constructed. Let me show you that implementation again. Go to definition here. So there will be this test request class object created, and that test request class object has got that same name, gender, address, age, email, phone number, pin code. But barring these few things which are coming from body, you'll find out there is something called as user details, something called as local date is there, and so on. Some consultation and lab result details as well. So you'll find out it's a amalgamation of what comes from a request plus some user related details. And this blend is something which is called as object of test request class. So when it comes to so-called your test request controller, okay, so what this particular method does, create test request, it collects the data from your body, it gets the data about your user, then it does the amalgamation of user and test data or body data and creates another object of class called as test request class, and then ultimately returns that test class request object for further processing. Now I would like to test this particular method. In order to test this particular method, somebody should be like, this is normal public method, right everyone? So to call this particular public method that we have got, I must be able to create an object of this guy first. So somebody should be able to create an object of test request controller. So test request controller object equal to new test controller. Then maybe test request controller object dot create request, and somebody must be passing this kind of a data as well. And then I will be getting some result over here, which I should be able to compare. So how do I test this? So for that purpose, you will find out test case with respect to test request controller, you'll find out will be written over here. So under the test folder, you'll find out there's a test request, one sample which is given to you. And you can just see over here, look at this. What is the name of the controller or class? Test request controller. So test request controller test is what is the name over here. Now this is going to be another so-called, you can say, class over here called as test request controller test over here. And test request controller test that we have got, this particular class will have something which is called as test create request. Now have a look over here, create test request out here. Let me look at it. I am not understanding the @ code. These are something which are called as metadata, Ravindra. So this is something which is important so that the JUnit or your mocking test framework can ultimately understand that this is the code that it is looking for. So behind the scene, there is a concept which is called as reflection. Okay. So normally these frameworks which are called as JUnit or something which is called as NUnit that we have got, these frameworks ultimately, they navigate through your code and they ultimately, look for something which is called as metadata. That is, that @ attribute thing. And they will ultimately execute the code which ultimately has got that @ thing. So it's not only about NUnit and JUnit. You will find out normally this is something which is called as attribute or annotation. So ultimately these annotations are always going to contain some extra information to several frameworks. So likewise, when I say over here, something like this, look at this previous content. Test request controller which you saw, there is something which is called as @ post mapping. So this is a metadata given to your Java code. Okay, ultimately your what we call as Spring Boot code. Something like, okay, you're telling to the Spring framework, okay, you need to execute this method whenever user types in and gives a request to some port number and says like, http:// localhost, maybe something, some port number /API/test request. So you are trying to tell to the, you can just Spring here, that is whenever so and so kind of a request comes up, that time please execute this method. So you are saying post mapping. So you are saying this request and this particular function. So user is directly not saying call this function. So creation of an object of this class and calling this particular method becomes a responsibility of this particular framework called a Spring. And then when that object creation happens, when this create request method gets called, whenever there's a knock on the server calling API/test request. Okay, so this is something which is extra information that you are telling to the Spring. Now if this stands for extra information to the Spring, you will find out here in this test case, you'll find out this is @ test. So it's an extra information that you are giving right now to the what we call as your unit testing framework, which means execute this piece of code that I have got over here. So how do you do the unit testing for this? So ultimately our code was something of this sort. Our code function name was create request. So I want to test my create request. Okay, how do I create request test? So you have got create test request. Okay, so to ultimately test my create test request, here is a code. Ultimately, there is a create test request object created behind the scene. Okay, there is a set address which is hard-coded address is given. Remember, sometime back, this data which we're talking about, this data is something which was given from a body part. Okay, but now obviously nobody's going to go and give a data over here through a body. So ultimately we are trying to have a simulation over here. So actual request may not be given, but then we are trying to simulate over here. Okay, this is as if I am giving address, age and email and gender and name and phone number and pin code from something which is called as a body. So it's a simulation function created, which is just going to go and create some test request object and return some test request object from here. Okay, after this what? So now you will find out here, if I just go a little up or down. Okay, let me go to test controller. Here we go. Yeah. So take an example out here. So ultimately what we expect over here, when test request create service, create request from returns valid expect as a response. In the sense, what we're trying to do is, if the request comes up and then there is something which is called as, let's say, assuming that user has given me a request, there's a body part of a HTTP which consists of some data. There is a user details as well who has logged in. Assuming that, we are just trying to see what sort of test request object we get. So there is a simulation. If you see, there is a user object created manually. Okay, so there is a function which is constructed in this program, a unit test program called as create user. Have a look here. There is something which is called as create user. Have a look. There is the hard-coded user detail. User ID is there and user name is there. Okay, some hard-coded user class object is there. So you create a user here. Then there is this thing which we saw. There is a hard-coded create test request, assuming as if the data is coming from the HTTP body. So there is a hard-coded body created. And what did I say some time back? You have a user details, you have a test request. Remember what I said? You ultimately create a what we call as amalgamation of both, right? So ultimately your test controller that we have got, it did create a user, it did have a test result, okay, test request, and then there is this function called which is called as create test request from, and there are two things passed, user and test request, body data and users data, and the blend of these is given in here, right? So what you are trying to do is you will be calling this method in a way. So ultimately, if I just go back over here, it is as good as you are trying to call. So called, you can see the mock what we call it as here. You are ultimately calling that controller dot create request, and you are passing that request object. Okay, and whatever you get in return is some result. And now you're just trying to check over here that whatever mocked response, which means you try to do the amalgamation of user and the test hard-coded test data, hard-coded body data, I would say. So hard-coded user and hard-coded body data, you did the blend using this simple function here, which is below written, and that particular function gave you the mocked response. Okay, which means this is something which is called as what we call as expected response. Instead of mocked, I will call it as expected response. And then what you do is, in between you call your controller / create request and pass on the data, and you just try to expect these details. So now this is like your actual result. So is what we call it as expected and actual that we have, are they equal? So you're just trying to check over here, assert equals, okay, result and mocked response. If they are equal, you will get a green sign. Otherwise, you will get a red sign in this case. Now, assert not null, which means result is not null. This is another test case that we have got, that we are assuring that result is not null. Then if it is not null, one green, then assert equals, so another green, if at all they match. So ultimately, as I said, this seems very boring, but then ultimately we are just trying to see that there is a user that we already know. There's a request data that we already know. So are we going to go and get this kind of, you can say, response from this particular method? So whatever is what we got as expected, does that mean it is equal to actual? If that maps, then we will say test case passed over here. Okay, so ultimately your unit test case is always resolved in three different, or you can say factored into three different parts. Arrange, in a sense, you actually arrange everything, which is called as, you can see, your input parameters, your expected result as well. You try to, make it, you put it. So there are so-called, you can just like in add method sometime back, there is a X and Y initialization, and there is a actual, rather expected kind of initialization. That is something which is called as arrangement. Then based on the input parameters, you try to act. In a sense, you actually call your functionality. That is called as act. And then whenever you get your actual result, try to compare it with your expected result. So are they equal? Are they not equal? Are they greater than, and so on? There are several functions like this are available in the several frameworks. So ultimately arrange, act, and assert. Ultimately check for equal. So you'll find out this is a AAA approach, we call it as. So arrange, act, and assert. This is something which every unit test framework typically follows. Arrange the inputs and expected thing, call the functionality, and simply assert over here. These are some, or you can say in some or other manner, or you can say to some extent, you'll find out 95%, 98%, you can say same things that we do in everywhere. So irrespective of the framework, whether it is Java or .NET or PHP or Angular, or let's say maybe React, it doesn't matter. We always go through this. We arrange, we act, and we assert. We make some inputs, we create expected code or expected output, and then we actually check the actual output that we get over here. It's that simple. Okay, so this is something that I just wanted to convey, what exactly UT means and so on. So as I said, code base is already shared with you. So in such cases, I would want that based on, you can say, some code base also, try to fill in the blanks into the application. Try to, you can say, run the code based on, you can say, some documentation which is shared with you, or based on so-called, you can say, some inputs which are shared with you on the upgrade platform, and then make it work. The purpose of this discussion was just to ensure that you understand the importance of UT in this case. So did you all get this?
Mahesh,
Yes, please.
yeah, I want to add point that it is, I know the importance. I got to know the session which was, it was created for the UT importance. I
Hmm.
got to know it, but actually the code is a little bit difficult for me to understand. I
Okay.
don't know if it is for all of the other students, but I am feeling it that it is something different, something more thing.
Yeah. So as I said, as we discussed last time as well, purpose is not to, you can say, I can understand that, code base is something which is difficult because, and code base is already shared with you. The only thing is like, we are not expecting that, people should be like, expert in Java. Uh, all people should be expert in something which is called as, you can say, maybe let's say UT or JPA or databases, for that matter. It is just to, you can say, once you understand one function, then maybe you can just understand other function that way, which means all over similarities you will find out. All over functions over here in UT, you'll always find out some similarity over here. For example, if I just pick up another maybe
So
thing
you
like
can
lab.
say, so you can say just by my common sense, if I can identify some issues and I can
Yes,
resolve them,
yes,
uh,
yes, yes.
that is the main purpose over
That's
here.
the main purpose. That's the only purpose. You'll find out. I mean, you pick up any of it. Let's say, suppose if I just have arrange act somewhere written, I guess it was only one sample that I had got over here. But let's take an example. Here it is. Something like, let's say, take an example. There is arrange over here, over here. Okay. Some simple phone number checking, I believe. And then there is something called as some inputs. Then there must be act over here. So actually you are calling some functionality, and simple assert is there that way. So you pick up the, you can say, functionality, and you'll always find out there are some samples which are given to you. This is for that reason that, that what does it mean by arrange? What does it mean by act? And what does it mean by something which is called as assert? Once you get to know, it's literally simple comparison that we'll have to do, okay, all the time. And by looking at some existing code, you can actually go and end up maybe writing some, you can say, other code base also. And if it is not done, then we are there on the forum, which will definitely help you in that regard. Something like, if something doesn't work, something, somewhere you face a issue also, we can always have so called, you can say, help available that way. So expectation is definitely not to be expert in Java. Expectation is just we just understand the, you can say, flow. Okay.
Yes, yeah. Thanks, Mahesh.
Yeah,
I will try to solve them with my common sense that what will the error, what will be the error,
sure,
and
sure,
then
sure.
place the fill in the blanks. Yeah.
Yeah, that is what is expected exactly.
Yes, I will not try to understand what is in the code or what is it trying to do with the list function or what is it trying to do with this all this code and the at the rate function. I will not try to execute on that. I will try to resolve it with my common sense. What is the
Sure,
function
sure,
and what
sure,
is
sure. Because obviously, as I said, like everybody, I mean, maybe let's say half or not half, even let's say 90% of the people may not be from Java background, may not be from database background, may not be from React background, obviously. So in that case, how will they understand this particular piece of code? So as I said, here use the, you can say simple, what we call it as, be analogy here. Try to see some function and try to use analogy with respect to other function, and that will help. And the function names are actually given in such a manner that we can actually understand them very well, which means the naming conventions used, at least the so-called, you can say maybe some comments which are used, you'll find that these are just definitely going to go and help you understand it in a easier manner. I mean, the understanding process is made easier that way.
Mahesh, this is Banu.
Yeah, hi.
Hi, Mahesh. See, you said there is an upgrade platform, right? Without installing this IntelliJ on any of the maybe office laptop or something, where can I practice this Java code?
No, this is, there is one thing, something like upgrade platform. I'm saying forum. Okay, so on forum you can post your queries, but I believe
Okay.
upgrade platform may not have everything interacted. I mean everything integrated. So, for example, React, which means basic, I can say JavaScript and basic HTML code is something which can
Mhm.
definitely you can practice on upgrade platform. Okay, which is there, but then the integration with something called as React and so called, you can say entire Java is something which is not done.
Uh,
Uh,
you can
so
you
my
can also
question
use
is, can
you can
can I?
also use Code Pro or other thing
Okay.
platforms like this.
Yeah, there
Okay.
you can
Code
yes
Pro and Code Academy, they are online platforms. You need not to install them.
no, but the
Okay.
problem would be Bhanu and Ravindra, problem will be if you code over there. Okay, ultimately what will happen is here there's an integration part which comes in picture. For example, this is just a Java code, and ultimately it will just simply expose some APIs which needs to be called by React code, right? So point will be something like, you can say that, you can say content will not be like, you can just, let's say you can simply suppose if you make so, if you somehow if you make it work, there is no assurance that you can say every framework is installed on those platforms even. So it won't be like, whatever we need really for Upstack, everything will be given to you. That is something which is, there is no assurance that we will have that is assured. That's the reason local, you can say, working is something which is always good.
Okay. I mean, my question is, I mean, without installing it, can we practice it virtually somewhere on the
Mm,
cloud or on the server?
I guess no. I mean, at least on upgrade platform, it is not assured because React. I can assure you, React is not there. And with respect to Spring Boot also, we need to check. But I'm very sure about it that you can say integration with respect to DB also will always be a problem. Integration with JPA will always be a problem in that case. So
Okay.
I really insist that do it offline.
Okay.
Yeah.
So highly suggested that we should install the application and then.
Yes. Yes.
Okay. Thank you.
Okay. So yeah, this is what I wanted to talk about today. So there's some question, I guess. Can we use VS Code? Again, VS Code will be helpful for React thing. Okay, on the client side part, VS Code specifically for this Spring Boot application is not going to go and help you, Srinivasan. So ultimately, using something which is called as IntelliJ is something which is advised. Maybe you can use Eclipse as well, but then IntelliJ will have a better support with respect to, you can say, the code base which is given to you. Okay. Yeah. Fine. So yeah, this is where we are going to go and end today's session, guys. So what I'm going to do is now I'm just going to go and stop sharing my screen, and then meanwhile, I get. Did you all get the code base, by the way? I hope you have received the code base. Link for earlier sessions. Okay. Srinivasan, point is, I do not have links for earlier sessions, but then if you can interact with some coordinator, that will help. I actually, work more like, you can say, more like a consultant. So wherein, I just deliver, you can sessions based on the mutual, what we call as time availability. So I may not have the earlier session links, but then if you can just get back to Keshav or somebody like, Asham, or somebody like, you can say, Niaz, who are the coordinators, or whoever is a coordinator assigned to you, I guess those people can give you, the links, or whoever you are interacting with for these sessions. So these people will be able to give you the earlier links. Okay. Yeah. Fine. Okay. Okay, that's fine. So if you have a code base, then try to install. I can say, as I said, IntelliJ, and then open the, you can say, code base directly into it. Open the workspace directly. Open the folder directly into it. Just like VS Code, you open the content. So that's it, guys. Thank you very much. It was, you can say, nice, you can say, discussion we had. So thank you very much, and have a good night. I don't see any kind of a poll over here. As in, I can't launch any poll. So maybe you will get offline link or something. Okay. So thank you.
Thank you, Mahesh.
Thank you all.